Alright, now first thing, we've got this chart filled in. Squares, square roots, memorize them, impress your friends, frustrate your enemies, this kind of stuff. Gonna have to know. The more you know, the easier it's gonna be to move fast, alright? So I've got it all filled out. Take a moment, take a look at it, make sure you've got it all right. I mean, they're inverses of each other, these two charts. Anyway, getting on. Simplify each number or numbers. I'm going to use the tree method. You don't have to use the tree method. It's just what I do. So I'm going to break this down. This is 36 times 3. The reason I want to break down the 36 is I can get a pair of sixes right now. 2 sixes pair up, one comes out. 6 square roots of 3. This one right here, take them, multiply them together. This is going to be the square root of 360. Again, I'm going to break down into 36 and 10. 6 is 6. You can break that 10 down into a 2 and a 5, but notice nothing's going to pair up. So you take 6 comes out, 2 and the 5 stays on the inside, and you'll get a 10 on the inside. So square root of 10. Over here, square root of 12 squared. These are going to be canceling functions, and so it's just going to give you 12. You can go 144 and do the square root of 144 if you would like to do that, but it's not necessary. This one right here, I'm going to take, and on the inside, I'm going to multiply by 1. And the way I'm going to multiply by 1, very specific. I'm going to multiply by 2 over 2. The reason I want to do this is so I can get 10 over 4. And when I break apart my squares, square root of 10 was square root of 4. That square root of 4 will go to a rational number. Square root of 4 is just 2. And I've rationalized the denominator. Number 3, just like number 2, these functions will cancel each other out. Square, square root cancel out, so this one's just going to be 25. You can also take square root of 25 is 5. 5 squared is 25, however you want to do it. This one, multiply by 1 again. Very specific, square root of 5 times the square root of 5 is 5. 3, going to be on the outside. 7 times 5 is 35. Can't reduce anything, all done. This one, 9 and 5, 9 breaks down into 3 and 3, get a pair of 3s, 3 comes out, 5 stays in. This one on the bottom, you can do it one of two ways. You can either take and multiply by the square root of 3 over 3, but up top, you just have the square root of 3 squared. So if we divide in, this is going to be the square root of 3. Let me show you the other way, just in case. We'll take square root of 3 over, or 3 over the square root of 3. We're going to multiply by 1. It's going to give me 3 square roots of 3 over 3. And the 3's will cancel, give you the same answer. So it doesn't matter which way you do it as long as you are accurate. Looking at number 5, 90. I'm going to get a 9 and a 10. Again, you can break that 10 down, but you know you're not going to get any additional pairs, so I'm not going to. Bring that 3 to the outside. 3 times 5 is 15. 5 is already out there, so we multiply the 3 in. And we get a 10 left on the inside. Again, you can break down that 5 into 2, but you aren't going to get any more pairs. Number 6. Break down that 50, 25, and 2. 25 will give me a pair of 5s. I'll break that y4 down into y squared, give me a pair of y squareds. That gives me a 5 on the outside, a y squared on the outside. This 2 did not get paired up, and this x did not get paired up. Now on the y4, if you're having trouble breaking down into the y squares, what you could do is you could break it down into y times y times y times y and get 2 pairs of y's, pull them both out, and end up getting the y squared the long way. Also possible. Also possible. 98. We've got 49 times 2. 49, give me a pair of 7s. 7 goes outside. 2 stays on the inside. And we're ready to go on to the back. They're going to hit you again with this square root squared nonsense. It's going to cancel each other out. You're going to get a 12. Same thing with the 25. Cancel each other out. You get a 25. Square root of 27. You get 9 and 3. 9 will give you a pair of 3s. You have 1 3 on the outside. That 1 3 that stays on the inside. The 20. We're going to go 4 and 5. So we get a pair of 2s. 3's already outside. 2 times 3 is 6. We've got a 5 on the inside. I've got a 45, XY4. Same process with the same XY4 from last time. 9 and a 5. I'm going to get a pair of 3's at this point. I've got my y squareds that are going to come out of that y4. So I've got a pair of 3's. One of them comes out. A pair of y squareds. One of them comes out. My 5 is going to stay inside, and my x is going to stay inside. Over here, now what I'm going to do on this one is something very particular. I can multiply these two together and get a massive number. It's really just 144 times 2, so it's 288. You know what? We're just going to go for it. We've got 288. I'm going to break out the 144 and the 2. And the reason I'm going to break out the 144 is I know I can grab a 12 and a 12 right off the bat and be done with this problem. So I've got a 12 on the outside. I've got a 2 that did not pair up. Done. This one, same process as the other one. I'm going to multiply by 1. That's going to give me the square root of 21 over the square root of 49. I know the square root of 49 is 7. So this one's going to be the square root of 21 over 7. This next one, just like you can't add x's and y's, we can't add radicals that are not exactly the same. So if I've got 2 square roots of 2, and I take away 7, that means I have negative 5 square roots of 2. After that, I've got 3 square roots of 3, can't push it together, so I've got to leave it separate. So I have negative 5 square roots of 2 and 3 square roots of 3 out there on the outside. These two, can't push them together, but they can be reduced. They can be reduced. So 32, 16, and 2. Give me a pair of 4's. 50 is 25 and 2. Give me that pair of 5's. So I've got 4 square roots of 2, and I've got 5 square roots of 2. This gives me a total 9 square roots of 2. Just like if I had 4x and 5x, 4 pieces of candy and 5 pieces of candy. I got 9 pieces of candy. Alright, the 2's don't change, your square root doesn't change. You just have 4 something, you have 5 more, you have 9 of that item. Over here on 21, they don't list it, but this is a 1 square root of 2. You have 1 square root of 2 right here. I add 6 more, that gives me 7 square roots of 2. Again, this 2 is not going to change. You have 1 of an item, you add 6 more of that item, I have 7 of that item. It does not matter what that item is. I've got 1 square root of 5, I take away 6 of them. It gives me negative 5 square roots of 5. This one doesn't look like they can push together, so I'm going to reduce. Get a pair of 3's. This is going to give me the square root of 6 minus 15. 3 times 5 is 15 square roots of 6. So 1 minus 15 gives me negative 14 square roots of 6. Right there. On this next one, same idea. I've got 32 is going to be 16 times 2. So 4 and 4. Grab the pair of 4's. 4 times 9 is 36 square roots of 2. Plus 1 square root of 2 will be 37 square roots of 2. On my next one, square root of 12 is going to be 4 and a 3. My 4 will give me a pair of 2's. And that will give me 2 square roots of 3 over here. So 2 square roots of 3 plus 6 square roots of 3 will give me 8 square roots of 3. And then I'm going to add that 2 square roots of 6. Can't push those two together because they don't have that same radical. Next one. I've got 3 square roots of 7, square root of 14. This cannot break down. I'm going to get 7 and a 2. There's no pair. But this one, the 4 and the 7, I can get a pair of 2's. It's going to come outside. There's already a 2 out there, so that's going to give me 4 square roots of 7. So I have 3 square roots of 7 plus 4 square roots of 7. That will give me 7 square roots of 7. And I will take off the 5 square roots of 14. It looks just like that. This one, distributing the square root of 5. 5 times the square root of 5. And then I have the square root of 5 times itself, or the square root of 5 squared. It's going to cancel out. So minus a 5. Can't push it much more than that. Next one. I've got the quartic root of 81, so I need 4's. I need a 4. So 9 and 9, I don't have a set of 4 yet. I break the 9's down, I get my 3's. I have 4 3's. They're all gone, so the radical goes away. 4 3's on the inside, 1 3 on the outside. The 4th root of 81 is 3. If you think about it, 3 to the 4th power is 81, so that works out. Your answer here will be 3. 64, again, we're looking for a set of 3, so I'm going to go 16 times 4. 16 breaks down into 4 and 4. That gives me a triplet of 4's. The 4's are coming out. Again, we need a set of 3, just like we need a set of 4 over here. And on this last one, I need a set of 4 for 16. So 16 is 4 times 4. 4 is 2 times 2. Again, I'm going to get that set of 4. set of 4 2s. Alright, let me give you an example. Just in case you can't find out what that perfect is going to be, let's give you an example of working it out the long way. So we'll take 32. Let's say you go 32 and you don't notice that 16 will give you a set of 4s right off the bat, and you break this bad boy down, you go 8 and 4, which a lot of you would. And then you break this 8 down and you go 8 is 2 times 4. Now if you see that pair, take it right away. You don't have to break those 4s down anymore. You got a pair of 4s, let's take it. Let's pretend again that you don't do that. You break those 4s all the way down. So we have our entire factor tree mapped out. This is where you grab pairs. I've got a pair of 2s, they're coming out. I got another pair of 2s, they're coming out. So I've got this one, I've got this one, and then I've got my 2 that did not pair up, it's on the inside. So I've got 4 squares of 2. Notice, that's the exact same thing that would have happened had we grabbed that 16 right at the front and gotten that pair of 4s right off the bat. It doesn't matter how you do it, as long as you don't do anything crazy. You will get that same answer. That's the algebra review.